This is a 2,000 horsepower quad turbo V12 that makes every electric supercar look incredibly boring. We've come to Italy to find out how they've made this thing the most powerful production car engine ever built. This is going to be a cool one. Me and Tombo are in Turin to visit somewhere that I've been salivating over on Instagram for a couple of years now. This is Italtecnica engineering, and the stuff they make in this building is an engine guy's dream. You know when you see a new supercar, hypercar or resto mod come out of Italy and it has a beautifully intricate bespoke engine? Chances are it came from this place. We'll be looking at their menu of stunning powertrains in this video, but for now, let's focus in on what is the most powerful production road car internal combustion engine in the world. The Giamaro V12. It's built for this thing, the Giamaro Cafla, and completely under the radar, this is now the most powerful production car engine ever built. Bugatti, Koenigsegg, none of them can match this thing for power. Let's digest what this is then. 7-litre V12 with 4 Garrett turbochargers in this hot V formation between the banks of the cylinders. Now normally a hot V is a single or 2 turbochargers. To fit 4 in, they've had to splay this V12 out to 120 degrees between the banks. That is double a normal V12 that's 60 and is halfway to being a flat 12. But when you want to make big power, gotta make room for them turbskis. The Danish supercar firm Zenvo put out a press release raving about their new quad-turbo V12 being the most powerful V12 ever made at 1,250 horsepower. They were surpassed a few months later by only 750 horsepower. Now, Hennessy might have something to say about the title we're giving the Giamaro engine, considering it's got a 2,031 horsepower Fury V8. I'm going to give the Italians the benefit of the doubt for now. Once both engines are fully finished, the dyno will tell all. To digest this engine even further, we've got some bits over there on a workbench, so let's scooch her over. Oh, she's a big girl. There she goes. There are a few things that make this engine really quirky, the chief among which being the crankshaft design. Now, to create 1,500 plus horsepower, it's quite tricky for a V12 crank to cope with that. Being 6 cylinders long, it's a long crank, so if you put too much load through it, it could be susceptible to twisting. They were worried about the rigidity of this engine's crankshaft, so they had to come up with an ingenious solution. It's really cool. So this is a standard V12 crankshaft, and the crank pins are at 120 degrees for a nice even firing order and a nice smooth V12. But the engineers here decided that that was risking the rigidity of the crankshaft. It could start bending and twisting. So they had to come up with a solution, and it's really, really cool. Instead of sticking to the canon of 60 degree offset, they changed it to 50 degrees, which means that this V12 is firing every 50 and then 70 degrees, 50 and then 70. They did the calculations on that and the crankshaft was staying way more rigid, so they stuck to it. Apparently, it's been a nightmare to machine those cranks, and we don't even have one today. There are only 2 in existence. One is in the prototype Giamaro supercar out there somewhere, and the other is in this engine here that's being built. So it's been a bit of a nightmare coming up with that solution, but ingenious nonetheless. So that's the crankshaft. The internals are forged, of course, with there being an anti-friction coating around the skirt of the piston and then an anti-detonation coating on the crown, both to maximize power but also the biggie, reliability. On reliability, there's no point in revving this thing to 9,000 RPM and creating 1,500 plus horsepower if the damn thing doesn't lubricate itself properly. That's where this comes in. The engine is split 2 cylinders at a time, and each of those 2 cylinders has its own oil scavenge pump. So think of this big slab here as 6 oil pumps in one. What this means is you have hyper levels of control of where and how fast the oil is lubricating the engine. That means you can create 1,500 horsepower plus and not have to worry about bearings spinning or cylinders being scored. Each scavenge pump has one of these in it. And my God, this is glorious to use. This is essentially the pump, and it almost works like a rotary engine. It sucks in the oil and then squeezes it out the other side while rotating around here. I could do this all day. This feels absolutely amazing. Can you hear that? Imagine that at some serious RPM. Oh, and it's machined beautifully, so it just keeps going. There's no snags. I'm getting weird looks there, I'm gonna say. Don't have a go at that. It's nice. The engine also uses a complete dry sump system, again, to maximize the control of the oil. And they really take it seriously here. There's a test bed over there where engines go on and there's no spark whatsoever. Their simple job is to test the effectiveness of their lubrication system to make sure oil is reaching every nook and cranny of even an engine the size of this. BMW, you listening? Take notes. Then comes the really pretty bit. Other modern engines have timing systems like this, but I'll never get sick of looking at them. The Valkyrie and T50 have fully gear-driven timing, and so does this. Born from the world of Formula 1, all of the slight amount of slack and give naturally produced by a cam belt or timing chain leaves the conversation, giving minutely accurate timing of the valves and pistons working in unison. The only belts you'll see in the engine bay of a Giamaro will be those running the alternator and the AC compressor. Just to emphasize how clever the guys here are, not only does this thing create 2000 horsepower, it's also Euro 6 compliant and US compliant. This thing can enter a ULEZ zone without any issues at all. Now, on the 2000 horsepower thing, I just want to clear things up just so I don't get in trouble with Italtecnica. This thing will create 2000 horsepower, just not yet. All the simulations and R&D see that as a nice, comfortable goal for this powertrain. Right now, we've turned up a bit too early in its development cycle, so they've ran this engine to 1500 horsepower very comfortably. The 2000 will come in the race mode of the CAFLA supercar, but there's going to be a bit more development to get to that figure. However, here is some dyno footage of it creating a very, very safe 1500. At 1500 horsepower, it is still the most powerful production V12 engine ever. The Bugatti W16 is up at sort of 1800, so it will surpass it, just not yet. So how did this engine come to life in the first place? I grabbed Italtecnica's technical director, Ricardo, for a chat. He is the first of many incredibly Italian men you'll hear from in this video. How did you end up with this engine? How did you end up with a 7-litre quad turbo V12?
Well, they wanted something very unique and very powerful. We thought about a 120 degrees V12 that is unheard of before. And so we had also the space to put the 4 turbochargers by doing that.
Okay. And right now, you've had this running at 1500 horsepower.
Yeah.
And simulations, I gather, have got it up at 2000. Even at 1500 horsepower, how do you keep a modern engine like this reliable? Because to me, when you're talking 1500, 2000, that almost takes you into like drag car territory where they're rebuilding these engines quite often.
It will be a streetable car engine, so it will have a longer overall period. And because it's, yes, 1500 horsepower engine, but it's not so pumped out to its maximum rating on the components to keep reliability. Mm-hmm. We are pumping around 1 bar, 1.2 bars of boost to reach 1500 horsepower. So it's not extreme values that you would expect from racing engines. It's a road car engine, so it needs to be reliable, and this will be reliable.
Okay.
Yeah.
What has been the biggest engineering challenge with this engine? Has there been anything that's been weirdly more difficult than you expected?
Yeah, one weird component to design was the crankshaft itself.
Yes.
Yeah.
50, 70 instead of 60, 60, 60.
Yeah.
How does that work?
120 degrees V12, you have firing events every 60 degrees. The downside of doing that is that the crankshaft would have bent and not withstand the power of the engine. And the torsional analysis is very important on V12 because of the very long crankshaft. And so we were able to make this trade-off between the firing events and the rigidity of the crankshaft.
Is that quite unique? Are there other engines out there that have that kind of staggered 50-70?
50-70, no, that I know, no.
Wow.
There is no other engine.
So what we're saying is you are clever as basically to come up with that. It's okay, yeah. You can say it.
You know, with the combustion engines, you always think you have arrived to the end, you know, because 15 years ago they said, oh, but combustion engines are arrived, 1000 horsepower, oh, you cannot go anymore because efficiency is not good, because regulation, because everything. But then you continue improving and you see that nowadays we are to 2000 horsepower.
What an engine. We are going to get some dyno action here today, but before we get to that, let's have an explore around this workshop. Let me show you some of the other ridiculous powertrains under this roof. This is just a taste of what Italtecnica do. This here is the Nardone Porsche V8. So if you've ever seen the Nardone Restobod 928 Porsches, they've essentially completely re-optimized that big 5-litre V8. Creates about 300 horsepower from stock. They've now got this thing over 500 and I've shed a whole load of weight out of it. Really, really nice job on that. Now, they haven't done any work on this, but I have to show you it. It's just sitting here for some reason. What do you think's underneath this bubble wrap here? You're wrong. It's a V16. How many of you remember the Devil 16? It was some supercar, hypercar that came out of the Middle East a few years ago, and it was touting a V16 engine up at like 5,000 horsepower. This is one of them. And if you get in close here, you can quite literally see it's two LS V8s stuck together. You know, people say that, oh, it's just two engines stuck together. This literally is. You can see the divide between the V8s. The bottom third of the engine has been properly remachined and is one thing, but up top, it is literally two V8s. Casually in the background, it's a Lancia 037 rally car, but you see the sticker on the side, 4-wheel drive hybrid. They reckon that is the first hybrid rally car. It was a student project. The Turin Polytechnic is a big source of automotive engineers, and this was one of their student projects. I did mechanical engineering at uni. I can tell you I was not doing stuff as cool and as extensive as that. Apparently it worked really well, but now it's just mothballed here. From God knows how big, 10-litre V16, whatever that is, you've then just got a little 1000cc Abarth block here. Freaking awesome. Okay, let's head over there because they've got another couple of their brand new engines being built. My engine guy's senses were soon drawn in by a sneaky test room off to the side of the workshop where I found head of testing, Danilo. You guys will know I love miniature things, and despite all the big heavy dynos kicking about, I think this is my favourite room. So Danilo, this is the kind of component test rig room, right? So I guess, for example here, instead of testing an entire camshaft, you've just got a couple of lobes here, and you can test these for what wear? Is that the main thing you're testing for?
Yeah, we can test them for durability, so the wear of the lobes, the wear of the tappet, the wear of the valve, the wear of the valve seats of all the components, and also we can make test on the function of the part. So we have a nice speed sensor on the valve springs, and we can test the movement of the springs that is correct as we designed.
Okay. So this is essentially, it's like a miniature cylinder head tester. So this is like a little fake miniature cylinder head. Got our cam followers there, valves down there, and then you've got your tiny little cam that'll interact with them, and it all in this little chamber here. So we'll fire that up in a bit. But also in here you can test oil pump. Is that
Yeah.
what this is here?
Yep, this is a collector for the oil, and here is where we put the oil pump, and then we have another collector that goes away in this way. We can change the pressure, we can change different type of oils in order to see which is the better for lubrication and also for power consumption, because starting from the inverter of the electric motor, we can see the power delivered each instant from the electric motor, so we can test also the functioning of the parts.
Okay, cool. Well, it's currently set up for doing an oil pump test, so we're not going to be able to see the full cam interacting with the little miniature cylinder head, but we're still going to fire it up, because I want to see that spinning. So please, Danilo, fire away. Look at that. They're off. So what sort of RPM is that just now?
1.2 thousand RPM on the camshaft. I can go.
So this is just above idle, basically.
Yeah.
Okay.
Something like I don't know, 3,000 RPM.
Wow. What, to actually visualize what 3,000 RPM looks like with a cam, the lobe shape just disappears visually. That's amazing. So we've got one here that's been tested. So there's quite a lot of, is that quite a lot of wear? Is that?
Yeah, this is too much wear. You can see it here. You can see that if you pass your finger, you can see that you can feel a scratch. So it is too much wear. This is for a project, for the V6 project. We made a lot of them with different shape of holes, different position of lubrication holes, also different heat treatment of the lobes in order to find the correct setup before installing on the engine. Yeah.
Okay, so how do you know if it's something to do with the actual shape of the lobe that's the error, or whether it's the oil grade you're using? How can you tell what's causing the damage? Is that quite difficult?
We start by iteration, so we made some simulation, we know where to see, and then we change a little bit in order to see if we are better or worse than the previous test, and then we go in that direction in order to find the better and the best performance ever.
Okay, cool. Amazing. Thank you. Oh, what a thing! How cool is that? This is really cool and a bit of an exclusive. We can't talk too much about this, but this is their brand new naturally aspirated V12. They had so much fun making the quad turbo that they wanted to get into the sort of Valkyrie Gordon Murray game. Can't talk too much about this right now, but here it is. We will be back to do a video on this when it's running. What a beautiful piece of engineering. We can talk about these. This is what they call the ITV6. This is in the Totem Resto Mod Alphas. There's a couple through on the ramp through there. Stunning cars. These are mid-build. These will be twin turbo V6s, creating about 600 horsepower, and they're really compact. They really cram in all of the ancillaries as much as possible into the volume of the engine. Really cool. I then grabbed the chief engineer, Carlo, to see how this amazing facility in northern Italy came about. Carlo, your father founded Italtecnica, so it's got a really cool story going back to the 80s. How did this place come about?
The company was founded by my father in 1985. He was working for an Opel racing team for Italy. Then there was the opportunity to start to work for GRB, for Peugeot, and he founded this company, Italtecnica.
When you say Group B Peugeot, I mean, there's one through there. So the T16 205.
Yes, is my favorite car.
Wow.
I have the dream to build one for me in the future.
Well, I have never seen a road car in real life. I've seen the Group B cars. To see a homologation one through there.
Yes.
Wow.
Consider that these cars were made only for homologation.
Okay, so your father worked for Jean Todt at Peugeot, because he was there. Yep.
He worked for Peugeot until end of 90s. I finished university, start to work here, and I understood that a small company like this, we are now only 30 people, cannot have a complete knowledge in all the car. If you want to achieve a very high level, you need to be focused in only one chapter. And the engine is my favorite. Then we start in engine development, but my dream was to project and realize engine by ourselves because yes, you know, if you work for big OEM, at the end the name is not your, is the OEM name.
Yeah.
And I would like make something mine.
This might be my favorite engine in the building. It's not a big flashy V12, it's just a 4-cylinder. But this is the 2.1 Chimera engine that you find in their 037 resto mod cars. If you've been to the Goodwood Festival of Speed, you will have seen this engine in those cars. It is a twin-charged 2.1-litre 4-cylinder. So back in Lancia's rallying heyday, the 037 had a supercharged 4-cylinder, and then it was the Delta S4 that had the twin charge. So what they're doing is putting essentially a new Delta S4 engine into the 037. So down here, we've got the supercharger that handles the lower RPMs. That then decouples at around 4.5, and the turbo then takes over. It is a stunning piece of kit. This might just be the best looking 4-cylinder engine I've ever seen. So let's hear on the dyno. On the way to the dyno, I couldn't resist looking at these. I've never seen this before. This is essentially raw, natural camshafts. So they've not been machined yet. So these will turn into lobes, but they're currently just these lumps of metal. You can kind of see exactly where they're going to be eaten into by these CNC machines. So that ends up looking like that. I don't know, am I just being weird? I find that incredibly cool. To the dyno. Danilo had set up the Chimera engine on the dyno and had it nice and warm and ready to give it the full beans. What we're getting here is a perfect demonstration of how that twin-charged 4-cylinder works. When this engine's just idling, the supercharger isn't running at all, just to keep it idling nice and smooth. Then, once it gets a bit up in the revs, you can see that clutch engage and the supercharger gets going. They say it sounds like a cow. That's kind of the nickname they've got for the supercharger, the cow, just because of that kind of groan it makes. Not like, you know, the sort of Jaguar screaming supercharger. I don't know, I really like it. It's very Italian. And then 4,000, 4,500 RPM, the clutch disengages the supercharger and it's all about the turbos. You can see the exhaust is bright red right now. It's getting hot. Such a cool engine. They're saying this one's running about 500 horsepower, and there's a development of this that's up at 600 horsepower. There it goes. There's Moo Moo. I want a cow supercharger on my car. It's freaking awesome. The first fire up, are you all?
Yeah. A lot of people here.
Yeah. Cool.
It's always like that.
Love it.
Also because we spent, let me say, maybe 1.5 or 2 years from designing and assembling and producing, because we produce the part inside. And so all the guys want to see that all works. Is like a baby for all of us.
Yeah.
So we want to see it running. So all the guys stop to work to make that work when they see hear it running and come to the test bench and see, oh, it works. Nice sound. So please running a little bit more. We only start now, please.
Can you please invite us back on one of those days? Because that sounds awesome. I want to be part of that. Yeah. After showing how the dyno worked and what the engine could do, Danilo kindly asked if I wanted a go.
This is 100% and you cannot push it anymore. The revving is really, really fast, so you can feel it. The first time for sure you really rev a lot, because you go until here and then you start to push really high, but you can feel it. It's not a big problem at the end because we have the brake, we are all in safety, so you can do it. I switch it on?
Yep. And I can just keep going?
Go a little bit more. Yeah. Wow. Okay. Yeah. And you can. There is a point where it starts to go really fast. Yeah.
Okay, that's enough. I'm too mechanically sympathetic to keep doing that. Thank you. Thank you.
No, no problem.
Does anyone try and mess about with you and do a bit of...
No, but every time we have someone there that beat with the hammer, and we are here, and we stop, and then it's not the engine that's knocking.
That's exactly why I asked, because I was sitting there and he fired up. I was like, oh God, shut it down. As an engine guy, I've been in heaven today, so a big thank you to Italtecnica Engineering for having us out, and I hope you enjoyed nerding out with me too. If you liked this video, it would be amazing if you could subscribe to my new channel to see more videos like this. Remember, what's for you won't go by you, and I'll see you in the next video. And just in case you missed it, engines are so bad.